Well, hi there, boys and girls. Today we're going to talk about concave inflection. So let's go ahead and look at a concave up picture. A graph is concave up if the little baby tangent lines, or f prime of x, is increasing. Also, you might notice that these little baby red tangent lines are below the curve. So let me tell you what I mean by f prime is increasing. The slope of this first red tangent line is pretty big negative. The slope of the next red tangent line is negative, but a bigger number. It's not as negative. Then we go to 0. There was our annoying bell. I apologize about that. Then it goes to positive, and even bigger positive. So we have an increasing tangent lines. Now, if something is increasing, how do we tell that? Well, we can tell something is increasing if its derivative. And what is the derivative of f prime? It is f double prime. So f double prime of x would have to be positive. That's how we can tell f prime is increasing. Let's go to a concave down graph happens when f prime of x is decreasing or getting smaller. You might also notice that the baby tangent lines is above the curve. So earlier they were below the curve, concave. Oh, by the way, I should have written this down. Silly. This means that we are concave up. Then, if f prime is decreasing or above the curve, we're going to call this concave down. And you can tell that the slopes go from positive to a smaller positive to 0 to negative and even bigger negative. So f prime is decreasing. Okay, a point of inflection occurs when we have a change in concavity. We are going to call that a point of inflection. P-O-I. Point of inflection, that happens there. Alright, so here's your definition if you want to write this down. If f is twice differentiable, that means we can find the derivative at least twice. We're going to say it's concave up if the second derivative is positive. We're going to say it's concave down if the second derivative is negative on that interval. So let's just get after a question here. At which of these 5 points shown are dy dx and d squared y over dx squared positive? This means f prime and this means f double prime. How are they both positive? Well, if f prime is positive, that means the graph would have to be increasing. If f double prime is positive, that means it also have to be concave up. CU for concave up. Where does that happen? Well, the graph is increasing after C, but a baby tangent line would be below the curve right here. So this is concave up and increasing, and that would be at the point D. Let's do some algebra. Find all intervals on which the function is concave down. So what I'm going to do is find the second derivative. So y prime equals 18x squared minus 4x cubed. Now y double prime, which is the second derivative, is 36x minus 12x squared. And what I'm going to do is very similar to what we did yesterday. I'm going to find critical points for y double prime or f double prime. I'm going to set this equal to 0. So I'm going to factor out a 12x. And this happens when x is 0 and when x is 3. So what we're going to do is draw a little line here, like this. Go back out to big screen here. And I'm going to put marks on the x-axis at 0 and at 3. But now I'm going to check f double prime and see what happens with f double prime. To the left of 0, like at -1, if I plug in a -1 to f double prime, I get a negative times a positive. 12 times -1 is negative. 3 minus -1 is positive. So I get a negative f double prime. That means that f is concave down. Now what about between 0 and 3? Let's try f double prime at like 1. If we plug in 1, I'm going to get a positive times a positive, which means f is concave up. And then let's plug in something like 4. F double prime at 4. And we get a positive times a negative. So 12 times 4 is positive, 3 minus 4 is negative, which is a negative second derivative, which means it's concave down. So from negative infinity to 0, union with 3 to infinity, we have concave down. Let's do one for a point of inflection. A point of inflection is where we've got a change in concavity. So I've got 30x to the fourth plus 30x squared for f prime. And then f double prime is 120x cubed plus 60x. And let's set this equal to 0. So we factor out a 60x, and I get 2x squared plus 1 equals 0. And this happens when x equals 0, and also when x squared equals negative 1, and that's like a question mark, because if you set 2x squared plus 1 equal to 0, you can't take the square root of negative 1. So we're just going to look here at x equals 0. Do our little number line, 0. And I'm going to check f double prime to the left. So like f double prime at negative 1. That would be a negative times a positive, which would be a negative. So we know f is concave down. And then if we try it to the right, f double prime at like 1, I get a positive times a positive. So f double prime is positive, so it's concave up. Change in concavity happens at 0. All right, let's take a look at this. For what value is the graph of f concave down? Notice that this is f prime. So concave down means f prime is decreasing. This is a graph of f prime. Where is it decreasing? It's decreasing from negative 1 to 1. So that is right there. So you might have to sometimes look at f prime to figure out concave up and concave down. So here's a little thing to remember. Concave up is like part of a smile. Second derivative is positive, concave up. Concave down is part of a frown. And that's the second derivative, negative. So anyway, that's all there is to concavity and points of inflection. I will see you guys tomorrow.